Part of our body systems unit is the digestive system. And we'll also look at pH and absorption, which is part of the digestive system. So what is digestion exactly? Digestion is essentially your body's ability, or the process of, breaking down large molecules into smaller parts and molecules, which then will be able to be absorbed through the small intestine, large intestine, and into the rest of your body. The way that this happens is through enzymes, which, remember, are types of proteins. It also helps that we have things like hormones, bile, which helps break down fat, and the nerves and muscles within our organs that help release the energy that the food that we are eating and digesting is producing, and then this energy is utilized and harnessed by our cells. Remember, like I said, an enzyme is a protein, and it helps speed up a chemical reaction. So we will do a little lab with a Jolly Rancher, you'll see, which is really fun, and you'll be able to see how that happens. And this is involved in every process of our lives, but very importantly through digestion itself. So the digestive system can look very overwhelming, but it's very simple, I promise. It is essentially the direct tract, which we call the GI or the gastrointestinal tract, from your mouth to your anus, okay? Your anus is actually the very, very last. It would go right here if it was listed. All right, so let's say that we eat an apple. The apple starts in our mouth. Our teeth help break it down. So you could technically say that our teeth are part of the digestive system, but I like to just sum it up and say the mouth and all its parts. And then we swallow it. And when we swallow it, it goes down our esophagus. Now remember, the esophagus and the trachea run parallel to one another. The trachea is your breathing tube, and it runs just on top of, so closer to your chest than the esophagus. But they do run parallel. So this is your esophagus, and as food is essentially going down your esophagus, it ends up in your stomach. All right, now you'll see there's this word, this epiglottis, okay? Epiglottis is this tiny little flap-like structure that's right up here that basically prevents food from going down your trachea. All right, so it's this tiny little structure, but it's very, very important in making sure that our food and our air are separated into the tubes that they need to go into. So again, we go mouth into esophagus, esophagus into stomach, stomach into small intestines, which are this really long pink structure, small intestine into large intestine into, I cooked something, rectum, and then anus would be the last part, and then it would be excreted out. Now you'll notice we have this dark green, this purple, and this yellow structure, and you're going, well, what are those? Those are our accessory organs. The pancreas, liver, and gallbladder. This is your liver. All right. This is your pancreas. Just kidding, this is your gallbladder, and this is your pancreas. And no food travels through these, which is why they're called accessory organs, but they each contribute their own tiny job to the process of digestion, which makes them very important. And yes, you will need to be able to label this, all right? But we'll have a little practice trial at the end of this PowerPoint. All right, so as I said, digestion starts in the mouth. It can be mechanical and chemical. And so what I mean by that is mechanical is essentially we do the job of your teeth. You're chewing, you're tearing, you're mashing, you're mixing. Anything that requires work would be mechanical. Chemical is going to be enzymes. So essentially the enzyme amylase, which helps break down starches and sugars, would be a chemical enzyme or a chemical digestion within your mouth. So this is where digestion starts, where it begins. And again, from the mouth, it goes down into the esophagus and then into the stomach. All right, so this happens through peristalsis, which is essentially a contracting movement of muscle in your esophagus and then through the rest of your digestive organs that essentially help bring the food all the way down. It's almost like kneading bread. So if you've ever seen anyone knead bread or even like massage, right? If you get a back massage, it's that same kind of rhythmic contractions that essentially is helping push the food through one system to the next to the next. The stomach can stretch up to 2 times its size, which is why we are able at times to eat a lot of food. And then it will originally go back to its size as soon as it's empty. From the stomach, or rather within the stomach, we have these special digestive juices called gastric juice. And they have a very, very high pH. And what this pH does is it helps break down the food in your stomach. It's extremely acidic. And then we also have pepsin in our stomach, which helps actually break down proteins. And then this makes our food into this substance called chyme, C-H-Y-M-E. Ooh. All right. So now we are going from our stomach into our small intestine, and the small intestine is broken into 3 parts. The first, as you can see, is the duodenum, right? So this is the stomach, and then we're going into the small intestine. So this part right here is the duodenum. It's the very beginning of the small intestine. Then we go into the jejunum, which is in the center. So this is all like the jejunum. And then last but not least, we end up with the ileum, which is right down here, okay? From the small intestine, we then go into the colon, or the large intestine. It's called both, which essentially scales like this and then out through the rectum. This tiny little structure is your appendix. So when you hear somebody has an appendicitis or an appendectomy, this is what they are essentially having removed. This little tiny, they say that it's about the size of your pinky nail. So if you look at your pinky nail, that's about how big your appendix is. All right, so when we're talking about the small intestine, digestion is continuing all the way down. The small intestine's main job is to absorb nutrients and to continue the digestion process by breaking down lipids and carbs. And again, enzymes and hormones from the pancreas, liver, and gallbladder are going to help in this area. All right, again, so the job of the small intestine, the large job, is to essentially absorb nutrients, meaning our body is pulling all of the important stuff from the food we've eaten, and it's absorbing through the small intestine wall and then back into our bloodstream and then back to our cells. So this small intestine wall is covered with lots and lots and lots and lots and lots of little things called villi. And then these villi are covered with more villi that we call microvilli. All right, so this is a nice little picture I stole from your textbook. This is supposed to be like the tubing of your small intestine. Okay, it's kind of gross, but it's true. If you zoom into these ridges, these are villi, okay? And then if you zoom into these villi, like zoomed in real close like this, they're a microvilli. These are very similar in job to the cilia and flagella of cells, in that they can create extra absorption or extra purpose of movement, but they're very, very similar to the alveoli in your lungs as far as creating more surface area. So surface area is super important for absorbing nutrients because, again, the more surface area you have, the more you can absorb. The more you can absorb, essentially, the more nutrients your body is getting and the healthier you are. They say your small intestines are roughly 7 meters long. It's very, very long. So think of a meter stick and then add those 7 together, and then that's all packed really tightly into your body. All right? So this big, large, super intense surface area organ, the main job is to absorb nutrients and then to essentially continue digestion into the large intestine, which is right here. All right, so here's our large intestine. So again, the large intestine can actually be divided into 4 parts. We have the cecum, which is right down here at the end. This, again, is your appendix. We have the ascending colon. It's like ascending up. We have the transverse. Remember, trans means across, so this is the transverse. And then we have the descending colon, because it's essentially food is going to descend into the rectum and out. The sigmoid colon is the very, very last part, right before the rectum begins. And the main job of the large intestine / colon is to absorb water. All right, so all of the nutrients have already been absorbed. Now we need to get water out. All right, so when we think of the colon, I want you to think of 2 things. I want you to think of diarrhea, and I want you to think of constipation. Both are lovely, lovely concepts, I know. All right, when you have diarrhea, what's happening is your body has eaten something or taken something in, you've taken something in, and it's not sitting well with your body. And so your body wants to get it out of your body. Your body wants to get out of your body. That makes sense, right? Very, very quickly. So what happens is the food goes down your esophagus, into your stomach, large intestine, and then to the colon. Again, your body is rushing to get this out, so the food moves very quickly through here and out. Because the main job of the colon is to absorb water, and because the food is moving so quickly to get out, the water is not absorbed, and therefore your poop is super watery because the water was not absorbed. So that's what diarrhea is. All right? On the flip side, constipation happens when you don't have enough water in your body, and essentially your poop takes a really long time to travel through the large intestine. And it can get kind of stuck. Now, it doesn't actually get stuck, but it moves very, very, very slowly. Right? So that's what constipation is. You basically don't have enough water or fiber in your body. Fiber can help bulk up stool and actually help it move faster. All right, so the main job of the small intestine is nutrient absorption. The main job of the large intestine is water absorption. All right, now we're going to change direction a little bit, but still related, and we're going to talk about acids and bases. Acids and bases, whoops, sorry, I thought I had a picture, are very important to digestion. I mean, in all body systems for the most part, but digestion especially because of the juices within our stomach, which are super, super acidic. All right, so what is an acid? An acid is something that releases a proton, which is another word for a hydrogen ion, which is another word for an H+, right, when it's dissolved in water. And so when we have an acid, we have a lot of H's and not a lot of OH's. Right, so we have a lot of hydrogen ions or protons and not a lot of hydroxide ions. So this is a hydroxide ion, right? On the flip side, a base is the exact opposite. It's something that actually removes the hydrogens from a solution. It has a low number of H concentration and a lot of OH concentration. When we talk about the pH scale, and this should hopefully be a review for you guys, we use a scale of 14, which identifies how acidic or how basic, or also alkaline, depending on your vocabulary, a substance is. So for example, 0 is the most acidic something can be. Okay, so 0 would be like melt the flesh off your finger acidic. And it goes all the way to about a 6, 6.5. And then when we get into the 6.5, 7.5 region, we're neutral, right? So neutral is like water, right? A lot of our things in our body are neutral. And then I would say from 7.5 to 14 is basic. Now, basic can be just as damaging for you as acidic, right? Don't mix the two up. They're both very bad when we get to these high extremes. And when I say bad, that's a relative term. I simply mean like if we were using a basic chemical, it could still do damage to your skin over here, just like this could over here, right? So they're very reactive. So again, this is like a happy neutral place. These are going to be super acidic. These are going to be super basic. A 14 is going to be more basic than an 11. An 11 is going to be more basic than a 9. And then flip side, a 0 is going to be the most acidic. A 2 would be more acidic than a 4. A 4 would be more acidic than a 5. So hopefully that makes sense. This is the extreme end of acidic. This is the extreme end of alkaline or basic. And then anytime you move away or towards the middle, you're going to kind of get weaker, quote unquote weaker, and more neutral. So these are just some things that you might find in the world that have a range of pHs. And so again, we're going to start with neutral because neutral is like our happy spot. Neutral is going to be like water. Our body also creates a lot of neutral things. So our blood is neutral. Our saliva is neutral. Our urine and sweat are neutral. Our tears are neutral, right? So a lot of the substances that our body creates or that come out of our body are neutral. Acidic is going to be things that, again, have a very high H+ concentration. So notice soda is actually pretty acidic. It's about a 3. And you'll notice this little snapshot shows you that's H, 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 H. A lot of H's, not a lot of OH's. So if I gave you this little snapshot on a quiz, I would say, is this a acid or a base? And you'd say it's an acid. And I know because we have 1, 2, 3, 4, 5, 6 H's and only 2 OH's. In our body, something that mirrors an acid would be gastric juice in our stomach, which helps break down different foods. All right, so that would be a good example in our body. Stomach acid right here. And then last but not least, we have bases. And again, bases are about 7.5 to 14. They are a higher concentration of OH ions compared to H+ ions. And this is going to be things like bleach, oven cleaner, sodium hydroxide, which is found in a lot of cleaning products like laundry detergent and such. That is also going to be very basic. In your body, you do have basic solutions like sodium bicarbonate, which your body actually produces to neutralize stomach acid, when your pH or when your body leaves homeostasis, our magical term, homeostasis, okay? So when you take something like a Tums or a Pepto-Bismol or a milk of magnesia, it's like an old school term for that kind of stuff, that's what you're doing. You're taking bicarbonate to help settle the pH or the acid in your body because it's probably too high. And that can happen for a lot of reasons. The most common is you ate something that just didn't agree with you. So again, this is kind of the pHs of the body. Notice how many things are neutral in comparison to things that are acidic. So here again, we have our acidic, which is our stomach juice, our gastric juice, HCl. Those are kind of all synonyms. And then we have our saliva, blood, urine, sweat, and tears. So HCl is a very acidic liquid, and it could actually dissolve the iron off of a nail, so rust basically within hours. Same with if you put a penny, like a rusty penny in a cup of Coca-Cola, it'll do the same, which kind of makes you question why you drink Coca-Cola, right? But HCl is really important, or gastric juices in this case, are really important because they help kill bacteria in our food as we digest them, and they also help with the digestion process. Again, they secrete bicarbonate, which is basic, and it acts as a buffer. And so what a buffer is it's something that essentially helps slowly or gradually change an acid into a neutral or a base into a neutral. And so buffers are really important, kind of to touch on this question, because like our body always does, sometimes homeostasis is difficult to maintain. And so when homeostasis shifts from one direction to another, we need to get back into that happy median. And so what happens is a buffer, for in this case bicarbonate, can essentially be produced by our body to bring us back to that start point. So back to a happy place as far as pH goes. So again, a buffer is something that prevents dramatic changes. It's something that kind of eases an acid back to where it needs to be, more neutral perhaps, or eases a base back to where it needs to be, perhaps more neutral or at least less basic. All right, so why are buffers important? I just kind of touched on this, but again, regulating blood pH, maintaining homeostasis, urinary and circulatory, same idea. Urine is supposed to be neutral. Sometimes it can get really acidic. Circulatory, sometimes our blood can get really acidic, so bringing it back down to a neutral pH scale. All right, now it's quiz time. Okay. All right, so you don't have to write this down, but see if you can name these. All right, so the green structure, the red structure, the pink, the brown, purple, green, and yellow. And yes, you will see this again. So make sure you're comfortable with it. All right, so the first one is the light greens. When I say green, I mean the light green, this limey green. That's going to be your esophagus. Okay. Next is going to be red, stomach. Next is going to be pink, small intestine. Next is going to be brown, large intestine. Purple, liver. Dark green, gallbladder, right here. Yellow, pancreas. So hopefully you get a great job, smiley face sticker. Pat on the back. Go tell mom you're awesome. Okay, that is all we have for today. I will see you guys tomorrow.